How does the Poynting vector describe energy flow? Imagine a wave traveling through space, carrying energy from one place to another. How do we know which way that energy is moving and how much is passing through? That's where the Poynting vector comes into play. It's a key idea in electromagnetism that helps us understand how electromagnetic energy flows in systems involving electric and magnetic fields. The Poynting vector is defined as the cross product of the electric field vector and the magnetic field vector. When you see the mathematical formula, it looks like this. S equals E cross H. This means it points in a specific direction, which is the direction that energy is moving. The size of this vector tells us how much energy is passing through a given area at any moment. Think of it as a way to measure the flow of power in space. In electrical engineering, this is very useful. For example, when working with antennas, the Poynting vector shows us how radio waves radiate energy outward. It also helps us understand how energy travels along transmission lines or inside waveguides and optical fibers. By knowing the direction and magnitude of the Poynting vector, engineers can design better systems that efficiently transfer energy without losing too much. The direction of the Poynting vector is always perpendicular to both the electric and magnetic fields. It follows the right-hand rule. If you point your fingers in the direction of the electric field and curl them toward the magnetic field, your thumb points in the direction of energy flow. This means the vector points in the same direction as the wave propagates. The magnitude of the Poynting vector tells us the power per unit area, measured in watts per square meter. This helps engineers calculate how much energy is passing through a surface at any given moment. When the fields are changing sinusoidally, like in most practical systems, we often use the time-averaged Poynting vector. This gives us the average energy flow over one cycle of the wave, which is very useful for real-world applications. The Poynting vector also plays a role in Poynting's theorem, which is a statement about energy conservation in electromagnetic systems. It relates the flow of energy into or out of a region to the change in stored electromagnetic energy and the work done on charges. This connection helps us understand how energy moves and transforms within electrical devices. In summary, the Poynting vector is a simple but powerful way to see how electromagnetic energy travels through space. It tells us both the direction and the amount of energy flow, linking the abstract electric and magnetic fields to the real transfer of power. Whether designing antennas, power lines, or optical systems, understanding the Poynting vector is essential for making efficient and effective electrical systems.